Hello, are you with me? Hello, hello. Can you listen to me? Can you hear me?
Are you talking to me?
To everybody.
We can hear you.
Okay, because
we
I see
hear you.
that I see the connection earlier was kind of like disconnected for like 1 or 2 seconds. Okay, now what is this 67%? If you think about it, when they say your discount rate is 33%, maybe I say, let me change the question maybe. If your discount rate is 20%, so what part do you pay? If the discount is 20%, what part do you pay? 80%, right? Does it make sense? Okay, so when they say discount 33%, then you will be paying 67% of that original price. So you see, if you stop here and you didn't go on, you will never learn that, or maybe you never realize that. But once we go on a bit further, okay, once you go on a bit further, that enables you to be able to compute how much you need to pay without first finding the discount. Okay, I have some little business on the side. Okay, actually, I send handbags to Indonesia in the past. So suppose, and the handbags that I sent to Indonesia, I live nearby Citadel. Okay, and they have that's an outlet for Coach, Michael Kors, Fossil, and some other brands. So when they say that you have $400 bags and the discount is 70%, how much do you need to pay? Now, plenty of people, they get so interested with the discount rate, 70%, they don't really count how much they need to pay. It's like your eyes focus on the discount instead of how much you need to pay. While the store actually don't care about the discount, they actually look at how much you need to pay, right? Okay, so it is possible that the bag actually just cost them $100, just cost them $100, but they purposely put the price for it. I'm not saying that's what they do, okay? That's not what I'm saying. I'm saying that as long as they make money, right? As long as they make money. So what happens if they have this kind of mindset, you know what, I will hijack the price high enough and then give a big discount because my customer focus so much on the discount rate and they lose attention, they get distracted from how much they're supposed to pay. So imagine, like if the discount is 70%, some people start using their calculator and count what is the discount, right? Can you tell me? If you're in business major, you're supposed to be able to do it fast. What's the discount amount? The amount of discount. 400 times 0.7, right? Okay, that's 280. Now, if the discount is 280, then how much do you need to pay? $400 minus 280, is it right? $120. Now the thing is, plenty of people in that store, if they don't really pay attention to that, the way they think is, oh, the discount is so big, it's 70%, it's $280. Just buy it, just buy it, just buy it. But they don't realize until they pay the credit card, right? Actually, not until they pay at the cashier. They actually, when they pay the credit card, then they realize, shoot, that handbag actually cost me $120. The sad thing is that handbag actually looked like a plastic bag. And you regret that, right? Okay, so they use the discount to distract you. Hey, that's marketing though, okay? I'm not saying it's wrong. No, I never say it's wrong, okay? I never say it's wrong. You are in business major, one day you may go into marketing and you know that's how actually customer behave, right? You distract them with a big discount, okay? So they think they save $280, but we get the sale, okay? if that bag is supposed to be sold at $100 and you end up selling it as 120, of course you should be happy, right? If you are the merchant, okay? You should be happy. Now, how to make you yourself happy and the customer happy? Give them big discount. They won't pay attention to this. They pay attention to this. This is their big attention. Okay? Hey, welcome to marketing. Right? Okay, so coming back here, suppose I want to go back and do it fast. I want to find the sales price. Knowing the discount rate is 33%, it means the part I need to pay is 67% of that original price. Okay, that's for number 26. Number 28. The area of a triangle with base 16 inches and height 8 inches. Number 28, I think it's on the easy side. The area of a triangle is 1/2 times base times height, right? Okay, so the area can be expressed as 1/2 times 16 times height. That's 8h. Now, some question to you. Why is the formula of a triangle is 1/2 base times height? The reason is because every triangle is 1/2 of a rectangle. Every triangle is 1/2 of a rectangle. Let's say, for example, I have this triangle. Let's say I have this triangle. Now notice that this triangle is fit into a rectangle, right? Now I claim that this blue triangle, the area of this blue triangle is half of the area of that rectangle. Why? Because of the following. Let me cut it this way. Make it a perpendicular here. Now notice that the area here is the same to the area here. It's the same. And the area on the right-hand side here is the same to the area of this part here. In other words, in this rectangle, there are two such triangles actually. Therefore, the area of a triangle is the area of the rectangle divided by 2. Now, where's the base? The base is here. This is the base. This is the height, see, right? But if you see that base from the rectangle point of view, that's the length. And the height of that triangle, if you see that from the rectangle point of view, the height of the triangle is the width of the rectangle. Okay, so it's basically the area of a rectangle. This is the area of the rectangle that we divide by 2. Okay, that's how we get the formula. Furthermore, number 32. Number 32. The amount of water in Q quarts of a liquid that is 28% water. So you have a liquid of Q quarts. How much water in there if this liquid is 28% water? So then 28% of that liquid is the water. Okay, so this is the liquid, this is the liquid, This is the percentage of that liquid that gives you the water. You can think of this, the 28% as the rate, okay? And this is the water. You can think of this 28% as the tax rate. So this will be the amount of tax. You can think of this as the discount rate. Then this will be the nominal for the discount. Okay. Number 34. This one is a bit difficult. The percent change from one month to the next month if the monthly sales are S1, S2. So this is the current month, this is the next month. What is the percent change? Let's do this. Let's deal with the change first. What is the change? The change will be S2 minus S1, right? That's the change. Now, I need to compare this with the sales the previous month. So the ratio of change will be the change divided by the previous month. Now, then I need to convert this to percent. So the percent change, how to convert a fraction to percent, multiply by 100%. Thomas, I don't get it. Okay, don't worry. If you don't get it, let's try some numbers. Let's say the sales in August is $100, 100 million to make you happier. Okay, and the sales in September, let's say, is $123 million. And then we would like to ask, what is the percent change? Of course, this is increasing, right? Okay, so yes, it is. There's an increase in sales, but what percent will that be? Then we first see what is the change. The change is 123 minus 100, right? That's 23. That's the change. Okay, now when we say the percent change, we should first take the ratio of that change to the base number, okay, to the number you start with. The change to where you start, and then convert that to percent by multiplying by 100%. So I use real numbers there, concrete number, discrete number in my last example, the one in blue. Okay, now then convert it back into, instead of 100 and 123, you use S1, S2. Okay, now that's how I get that number 34. Number 42, find two consecutive natural numbers such that, two consecutive natural numbers. So that will be, what notation do I use for this? Do you remember? Two consecutive natural numbers. Let's say n is the first one. What is the next one? The next one is n plus 1, right? Okay, great. So those two numbers are n and n plus 1, such that the difference of their reciprocals, so the difference of their reciprocals, so the reciprocal for this is 1 over n, the reciprocal for this is 1 over n plus 1. Okay, now the difference in their reciprocal, oh, by the way, can you tell which is larger, 1 over n or 1 over n plus 1? The one on the left or the one on the right is larger? Can you tell?
The one on the right?
The one on the right is larger? Let's try. Suppose we have 3 and 4.
No, it's the one on the left.
The one on the left is larger because we divide by smaller number, right?
Yeah.
Okay. Now, so when we say the difference of their reciprocals, it refers to 1 over n minus 1 over n plus 1. That's the difference of their reciprocals. Okay, is equal to is 1/4 the reciprocal of the smaller number. Which is the smaller number?
The 1 over n.
No. It refers to the smaller number of the natural number. Natural number smaller, the small natural number is n. Now, the reciprocal of that. The reciprocal of that. Okay, let's slow down. Okay, so we start with 2 natural numbers, right? So n and n plus 1. Agree? Okay, and then from there, we will deal with their reciprocals. 1 over n, 1 over n plus 1. Okay, so when they say the difference of their reciprocals, it refers to the difference of the reciprocals. That one is okay, right? The difference of the reciprocals is 1/4 of the reciprocal of. Okay, 1/4 of the reciprocal of the smaller number. Okay, so we look at the smaller number of these natural numbers, which is smaller. This is the smaller one. Okay, now then you take the reciprocal of that smaller number. You see? Now, I don't think they want us to solve this yet. Not supposed to. Okay, at least not now. At least, oh, maybe we can solve this, huh? Okay, so this is 1 over n, if I make it nicer, over 1 n plus 1 equals to 1 over 4n. Do you remember how to solve this? Did we go over this? And some space. 1 over n minus 1 over n plus 1 equals to 1 over 4n. One over n plus 1 is smaller for among these two. This guy is smaller. It is true. But they didn't say the smaller of the reciprocal. No, that's not what the sentence said. The sentence didn't say the smaller of the reciprocal. It says the reciprocal of the smaller. So you get the smaller number first, and then you do the reciprocal. Does it make sense? Okay? Yeah. It's a very good question. It's just what you asked me just now, the statement you make actually bring us to have a deeper look on why I come up with 1 over n instead of 1 over n plus 1. Why did I use this one instead of that one? Okay, and how the wording be if this is the one I'm supposed to choose. Okay, the reciprocal of the smaller number. So I get the smaller number first, and then I do the reciprocal. Then what is the wording, Thomas, if I want to choose this one? Then I will get the smaller of the reciprocal, right? Okay. Now the thing is, again, if we read too fast, we won't realize or identify the difference of those two. You know. Okay. Of course, I get used to it and such that I can read it fast and still get it right. Okay. But it takes a long process between me many years ago when I learned word problems until now. Okay, I learned, yeah, that's right, it's the wording. I learned a lot of mistakes. I make a lot of mistakes when I did word problems in the past, and it did took a very not only one, some very patient instructors to basically tell me, Thomas, slow down, Thomas, slow down, Thomas, slow down. One instructor is the one yelling at me the most. She actually said, Thomas, that's not how you waste your brain. It's like, read slower, don't waste your brain. Okay. If you do things hastily, if you kind of like rush in doing anything, you will realize that most of the time you waste your time. You know, you don't need to do a lot of things in one day. What you need to do is to do things right. And believe it or not, if you do things right, you will end up doing more. Because if you rush doing this and that, there's a chance that you need to repeat doing it because you didn't do it right the first or second or even the third time, right? Okay, now the thing is, once we have this set up properly, then we can do it, we can solve that better. Okay, the thing is, I don't know, let's try, let's see if you will understand this. I will multiply by the LCD. To solve this, I will multiply by the LCD, which is 4n plus 1. Why the LCD is 4n plus 1? Because I have n and n plus 1, that gives me this n plus 1, right? N, but I need to take care of that 4, that's why I have this 4 also. Now, then when I multiply each term by 4 and n plus 1, this first term here will become 4 times n plus 1. Why, Thomas? Because, let me write it here, 1 over n times 4 and n plus 1. Do you see what cancel? The n cancel, right? Okay. Now, likewise, the second term, 1 over n plus 1, when I multiply by 4n times n plus 1, what will that be? That will be 4n, because n plus 1 cancels, right? So the quotient is 4n multiplied by 1, that gives us 4n. Now, then the right-hand side here, multiply 1 over 4n by 4n n plus 1 will give me n plus 1. And I go on, 4n plus 4 minus 4n equals to n plus 1. On the left-hand side, I get 4. So n equals to 3. This question is not easy, huh? This question is not easy. So if n equals to 1, what are the consecutive natural numbers then? I'm not done yet. I only get the n. What do I need to find? My n, that the one I just found, is the first integer, right? Okay, I need the second integer. So the answer will be, those integers are, those numbers are 3 and 4. Okay. Oh, this question is not easy. So when you see my notes here later on, you will need to also listen to my lecture at the same time. Okay? You will also need to listen to my lecture at the same time. I try to get rid of the color so that we don't get overwhelmed coloring. Okay, let's go a bit further. Number 44, solve the percent equation. Sometimes the question in this kind of question is actually quite simple by first translating them only. What will becomes our x is equals to 175%, 175%. The word off becomes multiply 360. Now then you convert this to decimal. And then compute. Okay, I think that's fine. Cool. Is it right? Let me use my calculator to make sure. 1.75 times 360. Oh, that's 630. Right? 630. Number 46. 459 is what percent of 340? We divide this first. 459 divided by 340 equals to x percent. 459 divided by 340 in my calculator gives me 1.35. This is 1.35 equals to x percent. So how to convert a decimal into percentage? Multiply by 100%. Yeah, because what they want is what percent, right? So this is 135%. Number 48, 70 is 40% of what number? See, do you notice I just translated from the words into math equation? I just translated even to the point of word to word. Right? Okay, so then 70 equals to 40% in decimal is 0.40 or it's just 0.4. So x is 70 over 0.4. I think that's 175. Just use your calculator. I'm pretty sure it's 175. 350. Yeah. That's number 48. Go on, number 50. Discount. We love discount, right? Number 50. The price of a swimming pool has been discounted 16.5%. So the discount rate is 16.5%. Okay. Now, if the discount rate is 16.5%, how much you pay? What hard to pay? What percent? That would be 83.5%, right? That's coming from 100% minus 16.5%. 100% minus 16.5%. Okay, now then the sale price equals to 83.5% of the original price. That's 1210.75 equals to 0.835 of the original price. So the original price will be 0.75 over 0.835. Then you use your calculator, right? I get the original price to be 1,450. So you see how I did it? They tell me the discount rate, but I focus on what part to pay. Therefore, the sales price here is the part that you need to pay of the original price. By the way, let me share with you some personal story. Let me see how much more questions I need to. Okay, not too much. Okay. Let me share some personal story time. Some personal story time. I love personal story time. Okay. My teaching technique here in this number 50, you see that I keep on asking what part to pay. Okay. Change when sometimes when I did my master's study at Cal State LA, but the environment, the situation where I learned to change my teaching style on that happens when on my way back to Indonesia during one of the summer. Let me tell you this. My issue at that time is the following. When I give the original price, let's say P is the original price, and then I tell them the rate. Let's say the original price is $400, and then the discount rate, let's use lowercase d. The discount rate is 20%, and then how much is the sale price? The way I thought was I always did it this way. Okay, find the discount first. Find the discount first, and the discount is 20% times 400, right? 20% times 400 is 80. Okay, so the sale price is equals to 400 minus $80. That will be $320. So notice I did it in 2 steps. Okay, and I believe most teachers actually teach it this way. No, I mean, this is not wrong. This is not wrong. Okay, this is not wrong. But we get stuck with the discount first. We need to find the discount first before we do the sale. Okay, while in the end, what we care is how much I need to pay, right? Okay. Now, the thing is, if the discount rate is 20%, then I need to pay the part to pay 80%. Is that right? So the sale price will be 80% times 400. That's $320. So I get the same result. Okay, but notice that we can do the pay part 80% mentally. Right? Okay, now this right way of doing things, even though I knew I can do it that way before, I didn't think of teaching it this way to my students in the past until this is what happened. On my journey from America, from United States, going back to Indonesia, there's no direct flight from United States to Indonesia. I usually transit either in Hong Kong or in Taiwan. Then go back to Indonesia. My journey from United States, from LA, going back to Indonesia takes approximately 24 hours. That's a 13 hours flight to Taiwan and 6 hours flight to Indonesia, not including the transit, okay, and then check-in process, blah, blah, blah. All of them takes approximately 24 hours. Now, when I transit in Taiwan, so what happened in Taiwan was this. There is a store. I went to a store and there's a kind of like a poster up there saying 80%. But it was in Chinese. I don't read Chinese. So 80% what? Okay. Now, if you see 80% what on certain items, like they put it on a lot of some items here, right? What do you have in mind? I don't read Chinese, but my assumption is like it must be 80% discount, right? 80% discount. So I look at those stuff, and then I decide to buy a lot. Once I about to pay, they charge me so much, and I was like, wait. I do math. I teach math, and 80% discount should not give me this big number. It's supposed to be a lot smaller. So I talked to the cashier. I said, well, that's an 80% discount, right? But I use English, okay? And the cashier did not speak English that well, so she replied me in Taiwanese, in Mandarin. Okay, so we kind of like have a discussion. No, I said, no, this is not the price. And then she kept on replying me, that's how much you need to pay. That's how much you need to pay. Until somebody came to me, helped me translating, and I point to this board saying, this is 80% discount. And the person who translates for me say, no, that's not 80% discount. That says you pay 80%. So the number there is not the discount. The number there tells you how much, what percent you need to pay. So I learned my lesson there. I was so big with that 80% without knowing what's the next word say. So this is actually one way, a marketing method though, by the way, a marketing method. Instead of telling them 20% discount, trust me, they look at the 20%, they don't, and they always assume that's discount, like what happened to me in the past. Okay, but you can change that later on. You make the 80% big, and then the words here, you say, pay this part. Okay, so in other words, imagine if one day you see a poster saying pay 80%. Now, those customer eyes will look at this 80%, they don't pay attention to this pay. You know, okay. Now, once they are at the cashier, then they will be surprised that the discount actually only 20%. Right? Now, but using from this, what happened here, then I realized, you know what, instead of telling my students what is the discount rate, why don't I tell my students what part they need to pay right away? Okay, what part they need to pay right away. So once you have this 80% here, what you need to do with your calculator is basically 80% times whatever the price you have there. That's how much you need to pay. You see what I mean? Now, let's go back to that 1.3. I did number 50. How about number 52? A family has a monthly mortgage payment of $500, which is 16% of their monthly income. What is their monthly income? Oh, I think it's not too hard. This 500 is this which, right? This 500. 500 is 60% of income. 500 is 16% of income. I think you can solve it yourself, by the way, from here. 500 equals to 0.16 times income. So income equals to 500 over 0.16. Okay, you use your calculator. And the last one, instead of just browse through this section, I end up spending a lot of time. But I also hope the reason I want to invest this so much time for this section because I believe if you study, learn as much as you can from here, then you suddenly become a much better person when it comes to math. Okay, you are much prepared. Okay, number 54. The prices of various items are given from 2000 and 2007. Find the percent change for each item. Number 54. The change is the current price minus the original price, the base price. Then you use your calculator to compute this. If you're lazy, I mean, I can do it by hand, but I have calculator next to me. I will just use calculator. The change is $12.35. Now the percent change will be the change over the original price. Okay. Now, this will give us, if you put this into your calculator, this will give you the ratio change in decimal. Now multiply that by 100%. Will be 40.665%. I round to 5 decimal places for the decimal part. Okay, and for the percent part, I round it to 3 decimal places. So the procedure basically is you get the change first and then divide by the original price and multiply by 100% to change it to percentage. Last one, number 60. You are taking a course that has 4 tests. My class has 4 tests. The first 3 tests are 100 points each, and the 4th test is 200 points now. That's not what I have in my class though. Now, to get an A in the course, you must have an average of at least 90% in the 4 tests. Your score on the first 3 tests are, the scores are 87, 92, 84. Okay. Now, you need to average 90% to get an A. The question is, what must your 4th test to get an A? Let's call that X. Okay, let's call that X. For you to get an A, you need to score at least 90%, right? Average 90%. Average 90%. What is the total of these 4 tests? $500, not 400. The total of these 4 tests is 3 tests worth 100 plus 1 test worth 200. Okay, that's 500. Now, 90% of that to get A, we need 90% of that, which is 450. Okay, now your total has to be at least 450. So 87 plus 92 plus 84 plus X has to be at least 450. Then you solve for that. Okay, so you will get that your last point, your last test has to be at least what number to get an A. Okay, now your suggested homework from this 1.3, sorry for this long time. Your suggested homework for this 1.3 will be all odd numbers in this, all odd numbers. all odd numbers in this lecture. So basically, whatever you see here, whatever the pictures that I scraped from our textbook, do the odd numbers from here. Is it okay? And then on Tuesday, then we will do 1.6. Okay, on Tuesday we'll do 1.6. Okay, that's for today. See you then Tuesday.
Thank you.
You're very